All right, welcome. You know that feeling when you look at a massive cloud setup, all those servers, networks, databases, and you just think, how on earth do I manage all this without losing my mind? Well, that's exactly what we're diving into today. We're talking about the blueprint for modern infrastructure, how to turn that crazy, complex web into simple, manageable, and best of all, automated code. I mean, just let that sink in for a second. What if your entire cloud infrastructure, I'm talking servers, networks, the whole shebang, could be defined in a single text file? That's not science fiction. That's the core promise of infrastructure as code. And trust me, it is a total game changer for how we build and manage tech. And the tool that's really at the heart of this whole revolution? That's Terraform. Think of it as the master blueprint for your entire setup. You just write down what you want. I need 2 servers and a database, and Terraform is the genius that figures out how to build it. And the best part? It doesn't care if you're on AWS, Azure, Google Cloud. It just works. Okay, so that sounds great in theory, but how does it actually work? Well, Terraform has this really deliberate and, most importantly, safe core workflow. It's a simple, predictable 3-step dance that makes sure you are always, always in control. And it really boils down to just these 3 words: write, plan, and apply. That's it. First, you write your code, defining what you want. Then, you tell Terraform to plan. This is your chance to see exactly what it's about to do, like a preview. No surprises. And only when you've looked it over and you're happy do you give it the green light and tell it to apply the changes. It's such a powerful and safe way to work. And this here really brings that workflow to life. You see, you start by writing your infrastructure in those files we talked about. Then comes the plan stage, and this is your critical safety check. Terraform looks at your code, compares it to what's actually running in the cloud, and tells you, hey, here's what I'm going to change. And that apply stage? That's just you saying, yep, looks good. Go for it. Now, this brings us to a really important technical term, but don't worry, it's simpler than it sounds. Idempotency. It's a fancy word, I know. But the idea is this. If you run the same operation over and over, you get the same result. So let's say you tell Terraform to create a server. The first time you run apply, it builds the server. Great. But what if you run it again by accident? Well, Terraform is smart enough to see the server's already there, and it just does nothing. Run it 5 times, 100 times, you'll still only have 1 server. This is huge because it prevents all sorts of crazy errors and keeps everything consistent. Okay, so we've got the basic workflow down. But, using this for a personal project is one thing. Using it professionally with a whole team at scale, that requires some serious architectural standards. So let's dig into the key features and best practices that make this enterprise ready. Right, so for big teams, some features are just non-negotiable. Take remote state management. This is what keeps everyone on the same page. It's a single shared source of truth, so you don't have 2 people accidentally messing with the same server at the same time. Then you've got policy as code. This lets you set up rules like, hey, nobody can launch this super expensive server type. It's like having guardrails for your cloud spending and security. And drift detection, that's your alarm system. It tells you if someone goes and makes a manual change outside of Terraform, so your code always reflects reality. This table here is a perfect little cheat sheet for best practices. See that first one? Using remote state and making sure it's encrypted is crucial. It stops conflicts and keeps your state file safe. Then, structuring your code into reusable modules, that's just smart. It keeps things tidy and means you're not reinventing the wheel all the time. And finally, automating the whole thing in a CI/CD pipeline, with tools like GitHub Actions or Jenkins, that's where the magic really happens. It cuts down on human error and makes everything so much faster. All right, so Terraform has done its job. The house is built, the foundation is solid, the walls are up, but it's empty. We need someone to come in and actually furnish the place, install the appliances, set up the Wi-Fi. For that job, we bring in a specialist, and that specialist is Ansible. And this is such a critical distinction to make, what we call separation of concerns. Think of it like this. Terraform is the general contractor. It provisions the house. It creates the VMs, the networks, the databases, the big structural stuff. Ansible, on the other hand, is the interior designer. It furnishes the rooms. It logs into those servers Terraform just built and installs the software, applies the configurations, and manages the services. 2 different tools, 2 very distinct jobs. They work together, but they don't do the same thing. So, how do you get them to play nicely together? The best way is a clean handoff. Basically, Terraform builds the servers, then spits out a list of their IP addresses into what's called an inventory file. Ansible then just picks up that file and gets to work. Now, a quick pro tip. You want to avoid using Terraform's built-in provisioners to run Ansible directly. Why? Because they can be really brittle and unreliable if something breaks halfway through. A clean, orchestrated workflow where one tool finishes before the next one starts, that's always the way to go. Okay, so the house is built, it's furnished, and it was all done with code. Pretty cool, right? But how do we know it's actually built to code? How do we know the wiring won't catch fire? See, just because something is automated doesn't mean it's correct. And that's why we absolutely need a robust testing strategy. And we start by testing the blueprint itself. I mean, before a single piece of real infrastructure gets created, we can validate our Terraform code. This is huge. It lets us catch simple syntax errors, major security vulnerabilities, and stuff that doesn't meet our company's rules way, way early in the process. It's all about finding problems before they become real problems. And you've got some fantastic tools for this. First, there's Terraform Test. It's built right in, and it's perfect for checking if your reusable modules work the way you expect them to. Then, for the full-on integration test, you've got TerraTest. This thing will literally spin up your infrastructure in a real cloud account, run some checks to make sure it's working, and then tear it all down again automatically. And you absolutely cannot forget tools like Checkov. It's a static analysis tool that scans your code for security misconfigurations before you apply it. What a lifesaver. So our infrastructure code is solid, but what about the stuff inside? We have to test the next part of the pipeline too. We need to know, does our Ansible playbook actually do what it's supposed to? Does it install the right software and configure it correctly? And of course, there are tools for that too. The Ansible ecosystem has Ansible Test, which is great for quick sanity checks. Did I make a typo? Is the syntax valid? But really, the gold standard here is a tool called Molecule. This thing is amazing. It lets you test your Ansible roles in a totally clean, isolated environment, like a Docker container. That way, you can be confident your playbook will run predictably every single time, no matter where it's deployed. And this table just lays it all out so clearly. It really summarizes the whole testing landscape. So let's recap. If you're just checking the logic of a single Terraform module, the built-in Terraform test is your friend. If you need to test against real, live infrastructure, you reach for TerraTest. When it's time to test your Ansible roles and playbooks, Molecule is the tool you want. And for that proactive security scanning across your code, Checkov is absolutely essential. So there you have it. We've gone all the way from a simple blueprint to a fully built and furnished house, integrating both provisioning and configuration into one automated pipeline. But if there's one thing to take away from all this, it's that this incredible level of automation demands an equally incredible level of testing. The more you rely on code to run your world, the more you have to be sure that code is rock solid. So I'll leave you with this question to think about. Your infrastructure is automated, but is your testing strategy ready for it?